Thank you. Hello, everyone. Thanks for joining our session. My name is Nilesh. I lead product management for big data analytics at NetApp, and I have my colleague Karthik here, who is a senior solution architect for big data analytics.
Hey, guys.
So Karthik and I, we talked to several enterprise customers at NetApp who are trying to deploy big data IoT solutions. And during this interaction, we learned several data management challenges that these customers are facing. So today we'd like to share with you how our customers, first of all, what are those challenges and how our customers are solving those challenges using the hybrid cloud architecture that NetApp is proposing here. So this is a quick agenda for this session. So we'll start with, we'll define what are those data management challenges. And then we'll go over the proposed hybrid cloud architecture that NetApp has for addressing these data management challenges. And then in the end, my colleague Karthik will go over 6 different customer use cases that our customers are using this architecture for. We have question and answer in the end, so I appreciate if you can hold on to your question for the last section. So to begin with, we would like to define the IoT data flow, and that means how typically a data flows in an IoT application. As many of you know, in the IoT, there is a notion of edge and core, where edge is a place where most of the sensors and devices who are generating this data in real time. Once they generate this data, then that data comes back to core, where most of the analytics happens. So what we are seeing in our customer base is that we're seeing different kind of patterns. Some customers are consuming this data directly in their data center, and some customers are ingesting this data in a cloud. And this depends on where their IoT platform is deployed. But more and more, we are also seeing that many customers are using both. That means some of their analytics services are present on premises, but some of their analytics services are also in the cloud. And for some customers, they are actually consuming multiple clouds. And that's where there is this notion of a geo-distributed data lake that comes into picture, where customer wants to move their data across data center and the cloud. So this data flow, we kind of map it to 5 different data management phases. As you can see here, there is a phase, a collection and transport phase at the edge, where data is collected across geographically distributed endpoints. And then this data is transported back to the core using most optimal methods. So sometimes there is a real-time analytics also done at the edge, and also the data is aggregated. So those are the first 2 phases. Next 3 phases, they happen at the core, which is basically how you store this data in a most cost-effective way. Because as you know, there is a large amount of data gets generated in the IoT. So you don't want to, you need to be aware of the cost that you will be paying for storing this data. So how you store this data at most optimal way and also make it available for analytics to different analytics endpoints. And then the last point is like, how you protect this data. Many of these applications are becoming business critical. So you want to make sure that you're saving you're protected from data corruption, as well as you have a good backup and DR strategy for that data. So those are the 5 different phases. And largely, those map to 3 different data management challenges. So first is the flexibility. You want to have flexibility to use analytics at different places and ingest this data at different places. Also, you want agility. You want to able to create your Hadoop clusters and shut them down when you're not using it. So you really need to have a quick way of creating your infrastructure. The next is, as I mentioned, cost. You want to be aware of the cost. And then last is the data protection. So let me introduce NetApp Data Fabric. So NetApp Data Fabric is our vision and architecture for hybrid cloud. Going forward, we see that customers will use their enterprise IT, but they will also consume public cloud services along with their enterprise IT. And NetApp Data Fabric basically enables our customer to create next generation data center where enterprise IT and cloud will work in sync. And there will be a uniform data management across these 2 places where they will be doing their analytics. So let me define what are the building blocks of this architecture. The core of this architecture is the ONTAP operating system, which is very feature-rich operating system from the data management perspective. ONTAP allows you to do things like snapshot, clones, which are very quick and efficient methods of copying your data or creating a new instance of your data, which is stored on the ONTAP. Also, it allows you to do data tiering. So if your data, let's say your data is not really used for a while, we call it cold data. ONTAP automatically moves that data to a cheaper storage, and it saves only the hot data or data that is used on the more expensive flash media. Also, ONTAP allows you to do data reduction, like dedupe and compression of your data. So that is another way it keeps your storage footprint small. So ONTAP can be on premises, or it can also be there, what we call as NetApp private storage. So NetApp private storage is a basically deployment model where you deploy NetApp gear in a colo facility like Equinix, which is very close to the cloud. And then you can use the applications that are running in the cloud against the data that is stored on the NetApp storage. So in this case, you can use the cloud computing, but at the same time, you can control or manage your data the same way as you manage on premises. Also, there are interesting things you can do with this particular architecture. So SnapMirror is a way you can actually move data between your on-premises deployment and NetApp private storage deployment. It moves your data in the native format. It is compressed. So it is really optimized for moving your data over the network. So next component is ONTAP Cloud. So the ONTAP can also run as software-only appliance in Amazon or Azure. And you can, again, do the same things with ONTAP Cloud, where you can move the data from your on-premises to cloud, and then you can use cloud computing. And then the last component is Cloud Sync. For some of the applications, the data needs to be in Amazon's S3 store or Azure's Blob store. So for those particular applications, we have a service called Cloud Sync, which will keep your data that is on premises in sync with the data with your S3 storage bucket. That way, you can continue to consume your data on premises, but you can continue to consume your applications in the cloud. And also, the good thing is this works both ways. If your data is coming in the cloud, all these services are bidirectional, so you can actually create backup and DR solutions on premises. So let me introduce the new technology that we recently developed to simplify how you can do Hadoop analytics. As you know, the most common file system for Hadoop applications is HDFS. But it also introduces new complexities because you have to create a separate Hadoop cluster, and you need to move your data from your enterprise storage to this Hadoop file system. With this new technology we call in-place analytics, you can actually directly run your Hadoop or Spark jobs on the data that is stored on NFS. So you don't really need to create a data silo in HDFS. But there is another configuration where you can actually, if you have existing Hadoop cluster with HDFS, but some of your data is on NFS, you can actually start analyzing that data using your existing Apache Spark cluster or Hadoop cluster directly. And this model supports both hybrid cloud or on-premises model. So it gives you more flexibility in terms of deployment model. And this solution is certified by our partners like Hortonworks. So this is a very robust solution. And Karthik will talk about some of the performance aspects of this model. So these two things, right, the hybrid cloud architecture and in-place analytics together enables data fabric or hybrid cloud model for analytics. So as you can see on the left, you can actually use the NFS connector or the in-place analytics for running your analytics on premises, Or you can actually consume analytics services in the cloud, like Databricks or Amazon's EMR. Or if you are with Azure, then you can use HD Insight, and you can directly run these services against the data that is stored on NetApp private storage, or it can be on ONTAP cloud. And again, these are bidirectional services, so you can actually even move the data back or protect your data on premises, or you can also have a DR service on premises. So with that, I'd like to hand it over to Karthik, who will go over 6 different use cases that our customers are running using our data fabric architecture. Yeah.
Thanks, Nilesh. Okay, guys, I hope you had a very good keynote session. And before I start the customer use case, I would like to introduce 3 more guys, 2 technical directors. One is NPS technical director Shankar Pasupati. Another one is Pranub, technical director for NFS Connector, and product manager NFS Connector. That is this session all about NFS Connector. Okay, so let us start the customer session. Customers use cases. So these are the use cases we worked with the customers. We just want to share their experience with you guys. Okay, so this is one of the broadcasting provider. So this customer scenario is, so they have the data in AWS. They are injecting the data in one of the public cloud, and they want to do the analysis of that data in Apache cluster in the cloud. Once they done that one, they want to protect their data into the on premises. So the challenge, before I get into the customer scenario, all customer scenarios split out into 3 categories. One is what is customer wanted, what is their challenges, how we are addressing. So the scenario here is getting the data in the AWS and doing the process in the Apache cluster in AWS. Challenge here is they have 10 terabytes of data. Backing up of 10 terabytes of data is not easy. It takes a long time. And next one is they want to protect the data into on premises. That means data center for further process. This is the customer challenge. How we are addressing that? So my friend Nilesh already explained about the NetApp data fabric story and the data fabric building blocks. So in this case, if you look at that, on the left hand side, we have the Apache Spark cluster, and in the right hand side, say for example, Amazon Web Service, their cluster is running over there. Okay. In this case, if you look at that, okay, yeah. So Kafka is injecting the data into Apache Spark cluster, and they do the processing. So when they do the processing in EBS, the customer wants to take their 10 terabytes of data without disturbing the production cluster. There only we introduce a product called NetApp NFS Connector. Even Nilesh also mentioned about 2 deployment options. We can use NFS side by side with HDFS. The same methodology, same deployment option we use here. So HDFS running in EBS and NFS connector accessing the data from cloud ONTAP, and through which we are copying the data using Hadoop native commands, Hadoop DisCP. So once we copy the command to copy the data into cloud ONTAP is nothing but a NetApp software defined storage, through which you can transfer the data and you can do all the ONTAP functionality, and we are protecting the data into on premises using SnapMirror product. So this is the way we address that customer challenge. Okay. So next one. So this one is, this one is one of the IT service provider. This customer is, they are receiving the data in AWS, and they are doing the processing in the Apache Spark cluster. So their main objective is how do we reduce the solution cost? Because they have the almost 1500 clusters, 1500 member cluster. So, they want to distribute the cluster across multiple data center, and they want to manage it quickly in an efficient way. They want to leverage cloud computation. So, that is their challenge. So, how we provide the solution here? And one more thing is, they want to use the data across multiple data centers and cloud kind of scenarios they have it. So, in this case, how we are addressing this? So, first same thing here, they are injecting the data in the Kafka, and that data is available here in NPS. Okay? So, when the data is available in NPS, that same data, NPS is nothing but a NetApp private storage, is a private cloud kind of things, completely secured data, that is customer managed location. And that data available for multiple cloud providers. At the same time, through SnapMirror, we can protect into ONTAP, and the single data now accessible from multiple cloud providers as well as from the on premises using NFS connector.
Yeah, one point.
Yeah, please go ahead.
Yeah, one point I want to highlight that like this, when we compare the cost of this solution, where you are ingesting data directly on NPS was like close to 50-60% lower than if you ingest your data directly in S3.
Exactly, exactly. And we also observed recently, so NFS connector data is performing 10 to 20% much better than S3 storage. Okay, so the next one is one of the largest insurance company. So this company is just a reverse. The data is available in on premises. They want to use the data in cloud and multi data center location. The challenge here is the data is 7 petabytes of data, and they want to leverage the same thing, cloud computation. They want to leverage it. That is the challenge they were having. So, how we address this? So, here we inject the data in the on premises, and the data transferred or protected into the NetApp private storage using SnapMirror, and it provisioned to multiple service providers. That means AWS have Databricks, HT Insight through service level offering. They can use that one, through which this is like a consumption model. Use it and pay for it. Just use whatever you use, just pay for it. That way we address that solution. Okay. So, the another one is one of the largest bank customer. So, this customer is very simple. They want to back up their data, customer data, and the backup is, but the customer wants to leverage Hadoop native commands. At the same time, they want to get a better backup window. That is what the current problem they are having. It takes a long time to take the backup. And how do we minimize the performance impact on the Hadoop cluster, Hadoop Apache cluster? Okay. How we address this? So, this is the typical backup solution the customer is having. One is the Hadoop cluster, Hadoop distributed file system on the top, and they are using Hadoop native commands with the Hadoop DisCP. I hope some of you guys are aware of that. With a snapshot technology, we can copy the data, only the differences to the backup HDFS node. Once they copy it into backup HDFS node, they are using HDFS NFS gateway, through which they are taking the data out of it for taking into the HDFS tape library. So, in this case, the one problem they are having here is the performance. When they are using HDFS NFS gateway, during the copy of data, it consumes a lot of Hadoop resources from all the nodes. That means it affects their performance. How we address that? There are multiple solutions. We just pick two solutions. One is solution A. What we have done is, instead of using the local storage, NetApp storage directly provision into JBOD servers, and the data is directly writing into the NetApp storage on HDFS file system. So once the data is available in NetApp storage, NetApp technologies, NetApp enterprise management functionalities such as backup, restore, cloning, and all the NetApp enterprise functionalities, we can use it, and all the operations are happening at the storage level. That means backup. So this is the way we protect one solution. So in this solution, backup is archival also possible. Once the backup is available, using snap mirror vaulting technology, we can transfer that backup into different locations. Second solution is, we introduce one more server, backup server here, and in this case, we first solution from HDFS into backup solution using Hadoop native commands. We are using snapshot functionality. Once it's come to the snapshot in the backup server, in the backup cluster, we are using NetApp NFS connector to copy the data to the NetApp storage. It is completely offloaded the functionality, and once the data available in the NetApp storage, we can use all the enterprise management functionalities. Okay, so one of the another customer scenario. This is one of the online music distribution company. They want to create a multiple Hadoop cluster with very minimal time, in a minutes. So multiple clusters based on one cluster for dev test, reporting, different branching locations. But they want to create a multiple Hadoop clusters immaterial of the size of the data. Big data, you know that, right? The data is very high in big data. How we address that? We have a technology called NetApp FlexClone. So FlexClone is nothing but it's a read-write copy of your backup. Backup means snapshot here. So we create the multiple FlexClone volume, and then it provision to multiple cluster on the fly.
Yeah, I think one point here is that it doesn't really create copies. The technology actually, it's just a metadata operation. So it's an instantaneous copy.
Yeah.
You don't really actually spend time copying the data.
Exactly. It uses, whenever you modify the data, that delta only consumes space. Okay. Okay. The last customer scenario, one of the online marketplace. So in this one, this customer wants to use object storage. So for object storage, so you know that, right? NetApp has a product called Storage Grid. We have a product. So how we are addressing the challenge here is, the customer wants to use the object store data for big data analytics. That object store can be a primary site or it can be a secondary site. So same thing here. Storage Grid is the NetApp product which uses which is used for storing object store. We are considering as an object store. And using S3, we can access those data. It can be the primary location or it can be a secondary locations. Using S3A connector, we can access those data. So that's the way we provided for this one. And one of my, Nilesh also mentioned about another one, Fabric Pool. So that can provide archival of your data into object storage when the data is cold. And one more thing, just a performance. So in this performance, we have done the performance. I just want to mention two things in this slide. On the left hand side, the last one, that slide is duration, how quick we complete the operation. This one is throughput. Based on our validation with the high bench, you know that is one of the industry benchmarking for Apache Spark, 1.5 terabytes. we able to get 52% better performance. Okay, so based on these customer scenarios, these are some of the takeaways here. One is we can use our solution for hybrid cloud as well as multi-cloud systems. I hope you remember that. That is largest insurance company using that one. And rapid provisioning with the dev test, that is the largest one of the multiple cloud, there is multiple cluster creations. Another one is the cost perspective. The storage and cost are works independently. You can add storage on demand. And number of copies, one of the important one. You need only one copy. You do not require 3 copies. So you are saving almost 66% of storage capacity. And so data tiering using fabric pool, that means very simple, hard data only used for the Hadoop cluster, cold data transferred into storage grid using data fabric, fabric pool, and then management functionalities. So please come and see our booth 5 and 2 for further. Please visit us in the booth. We have a lot of solutions over there. I would like to open for the QA. Sorry, we have 3 minutes. We will try to answer most of your queries. If not, we will take it to offline to answer your queries. Please go ahead. No, it's okay. Go ahead.
So the first question was like for the 10 terabyte data that you guys are looking to on tap, how long does it take, or like pretty quick, or?
Oh yeah. So in this case, first one is when you are injecting the data into cloud. If you are using direct connection, that means AWS direct connection, multiple pipe based on the pipes, 10 gig pipes. If you have a multiple 10 gig pipes, because the data resides in the NPS. So NPS solution you are asking, or cloud on tap you are asking?
Cloud on tap.
Oh, cloud on tap. So when you are using cloud on tap, if you are using 10 gig pipes over there, based on the number of mappers, 2 things you need to consider. Direct connection between the data instances. Second one is mappers. If you increase the mapper size, we can get close to 2 to 3 hours of time, because it's copying only the differences of data. Second question.
So the second question was like for the planning power in here, and I mean from the cloud to your on-prem.
Yeah.
What is the connectivity? I mean,
Yeah.
for example, what is the connectivity? What is the security? Of course, you guys are using security, but is the data encrypted, or I mean, how you guys?
Yeah. So here, that is one good things for the most of the customer ask this one. NPS is the kind of your own private data center. It is like Equinix. In the Equinix data center, you can have your own space. So your storage is available over there. So that data to your data center on premises, the Equinix providing the separate firewall for your data. It is completely in your control. The data is completely in your control. When you are transferring the data, you can encrypt your data as well. Data encryption at rest, we are providing that.
There is a question.
Okay. Yeah, go ahead. Yes.
So when we personally use Amazon S3, Amazon Cluster Database, so we have our data on S3. So whenever we have a need for creating multiple clusters, what we usually do is we have a bootstrap script which have a similar as production, which is replicate that. We have a fixed bootstrap script, and we share the metadata to create similar clusters so that it portrays the same data. We particularly have the data on S3, we don't have it on HDFS.
Oh yeah.
We decouple the cluster and the data.
Okay.
So this is a quite simple thing which AWS is already providing, right? So when we were talking about
Flex clone. Yeah.
what does it do additionally?
Yeah. So very good question. Here is in the flex clone perspective, what we are doing is we are taking the same concept. We are taking the snapshot of the data, that is a metadata, and snapshot is the read only copy. we cannot write into that one. So, what we are doing is based on that snapshot, we are creating a volume. Volume means some kind of disk, a read writable disk, and that disk, whenever somebody trying to read the data is going to the source. When somebody trying to write the data, that delta, whatever the modification, those only consume space. So, here one important thing is, we are not doing anything in the Hadoop cluster. Everything we are doing in the storage layer. Because of that, the customer production problem, production system and cluster does not have any impact. Everything we are handling in the storage layer. The reason here is the data is very vast.
Yeah, and one more thing is, this is also, like I agree, like you're saying S3 can do it, but it is only in Amazon, right? So it's our key advantage, this is hybrid cloud. You can actually do the same thing in one cloud, multiple cloud or on premises. And you don't have to incur the S3 cost for doing that. So those are the key.
Very simply we can say multiple cloud providers can access the same data at the same time. Yeah, go ahead. Okay, any other questions please? Yeah, if you guys have any more questions, can we take it offline? And thank you for coming to this session.